everyone, welcome to lesson 11.4. So please have ready today the notes handout that is attached to the Edpuzzle link in Google Classroom if you have the ability to print, or a notebook to take your notes in works just fine as well. You can follow along and copy the diagrams. A pencil will also be necessary to write that all down. All right, so on the note sheet we see here just some review stuff. So a reminder, we have 4 different ways to prove triangles congruent: side, 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 angle, side, angle, or angle, angle, side, okay? And we want to decide, are these triangles congruent or not, and by what method? So in this first one, they gave us a pair of angles congruent and another pair of angles congruent. And something we can assume from the diagram is that they have also that reflexive side in common, so that that's congruent to each other. So this would be a situation where the triangles are congruent by angle, side, angle. In letter B, again, we have this reflexive side in common, and then we have another pair of sides given, as well as a third pair of sides. So these are congruent by side, side, side. In the example C, they do not share a side in common. They also are not vertical angles. And then unfortunately, they only give us a pair of sides and another pair of angles congruent. So in this case, this one is not enough info to officially state what they are, because we need at least 3 pieces of information. And last but not least, in example D, they gave us a pair of sides and another pair of sides with 2 tick marks. And we can assume then that the vertical angles are congruent by the vertical angles theorem. So that would be a pair of angles. So we have side, angle in the middle, side, to prove that these are in fact congruent triangles, okay? Now there is officially a 5th way to prove triangles congruent that we're not going to use very often, but I want you to be aware of it, and it's called hypotenuse leg. And basically you need 3 things to prove that as well. You need to have 2 right triangles. You need to have a right angle present and state that they're right triangles. And then the hypotenuses need to be congruent for the hypotenuse portion of hypotenuse leg. And then a set of legs need to be congruent for the leg portion, okay? So in these examples here, these are congruent by hypotenuse leg because they're right triangles. The hypotenuses are congruent here with the 2 tick marks. Legs are congruent with 1. Same thing over here. Hypotenuses are congruent, so are the legs, and they're right triangles, okay? So we want to state that if they are, we're going to state that here, or that there's not enough info. So in this particular problem, we see that we do in fact have the right triangles, so that's checked off. We also have a pair of legs congruent right here, and we're able to say that the hypotenuses are congruent because as we know with the reflexive property, this side that they share would be congruent, and that also happens to be the hypotenuse because it's across from the right angle. So this would in fact be able to be proven congruent using HL. The other problem here is not going to be able to be proven congruent by HL because we have right triangles and we have, by the reflexive property, the legs congruent. Unfortunately, though, we don't have enough information to say that the hypotenuses are congruent because they did not tell us that, and we cannot assume that. So this one is a not enough info situation because we don't have enough information about the hypotenuses. Now again, we're not going to use this very often, hypotenuse leg, but I did want you guys to see it in case you ever see it in your mathematical futures. All right, last new bit of information then from 11.4 is asking us to look at each of these and say, if I wanted to prove these triangles congruent by this particular method, what other piece of information would we need? Now, notice in this first picture, they gave us that these angles were congruent, okay? So basically the angle portion of this we have given to us. We also are allowed to assume by the reflexive property that DB is congruent to DB, right? So that's a pair of sides. So basically we would need another pair of sides given to us in order to prove these congruent by side, angle, side. Now we specifically need it to be side CB and AB because we need it to be side, angle in the middle, side. Okay, if they gave us DC and AD, that wouldn't do us any good because then it would be SSA, and we know that doesn't work out. So the answer here is we would need side CB congruent to side AB in order to prove this by SAS. Now in example B, this time they gave us a pair of sides, okay, congruent. So that's good. So we have that taken care of. And we're able to assume that the vertical angles are congruent. So that takes care of one of the pairs of angles. Now we also need another set of angles. Now specifically, we need angle N congruent to angle L. Now the reason we did not want it to be J and M is we want it to be AAS, not ASA. Angle, angle, side, not in the middle. Angle, angle, side, not in the middle. Had we said J and M, then we would have had angle, side angles. So that's why we had to decide on angle N needs to be congruent to angle L, is what we would need given to us. Now I want to end this by reviewing some more stuff with proofs. So again, with proofs, we always start with these triangle congruence proofs by writing down our given information and marking our picture. So for this first example here, we have AD is congruent to CD. So I'm going to mark that in my picture, and I'm going to write that that was given to me. So I use the first given. I also was given that angle ADB is congruent to angle CDB. So this angle is congruent to that angle. It was also given to me. So I'm going to write that down. Now the next thing is we know that BD is congruent to BD. Anytime something is congruent to itself, I know that that is because of the reflexive property. And now I know I have a pair of sides, a pair of angles, and another pair of sides, so I can prove these triangles congruent by SAS. Now, what if I now wanted to prove something beyond that? What if I wanted to say AB is congruent to BC? Maybe that's what my next piece I would actually be trying to prove is, that this segment is congruent to this segment. Well, the extra piece beyond that, once you prove your triangles are congruent, you can say then that these are congruent by CPCTC. CPCTC. Because, for instance, we can say those are congruent because we know that the triangles are congruent, so their pieces would need to be congruent. So if they're asking you for parts versus just triangles, that's when CPCTC would be used. Okay. Now, in this particular problem, they didn't, but if they had, we would have to do all this proof first and then add in that last step. Let's try another one. Okay. For this particular picture, notice they gave us the two givens written down. So we're going to start by writing the givens into the picture. So we have angle K is congruent to angle L, which I'm going to mark in my picture, angle K and angle L. And then they also gave us that KH is congruent to LH. That was also given to us. So KH and LH. And then last but not least, they told us the vertical angles are congruent. Now that's the bow tie piece here we have, right? Now we need to be careful with this though, because we can't just say angle H is congruent to angle H because there's too many angle H's. So we need to make sure we name this correctly. One way we can name it is KHG is congruent to angle LHJ. Because blue to H to unmarked, blue to H to unmarked. Again, lining up those corresponding angles. Okay, and again, vertical angles are congruent. And finally, we can say that our triangles are congruent because we have angle, side in the middle, angle. Angle, side, angle would prove them congruent. And again, if we wanted to prove another piece of information here, congruent, we would use CPCTC. So for example, if I said, oh, I actually want to prove that GK is congruent to JL, we would use CPCTC. All right, but we did. We will work more with all of this in class then. See you guys tomorrow.